All right, we're going to go ahead and do the second problem of Chapter 21, Homework Part 3. So this is I think, page 58 in your packet. All right, so this is about the groovy lottery tickets that are supposed to make up 30% of the total Scooby-Doo lottery tickets sold. And then they take a sample, and they have a sample of 250, of which 55 of them are groovy prize winners. A zealous customer wishes to take the lottery commission to court for false representation on the proportion of its totally groovy prize-winning lottery tickets. So what we're going to look at first is defining the proportion of what the p-value or the parameter is. Okay, so our p proportion is, of course, the proportion of the lottery tickets Okay, so our P is the proportion of lottery tickets that are groovy. All right, and then our null hypothesis is that the proportion of tickets is 30%. And then our null hypothesis, or alternative hypothesis, is going to be that that is going to be less than. Because, you know, I know that it doesn't state a particular direction, but we certainly would not take them to court if the number was too high. So we're going to go with less than 0.3. Okay, so in context, describe a type 1 error. So type 1 error is when the null is really true, but you get a sample that causes us to reject the null. Okay, so the null is true, but we get a sample. It causes us to reject it and think the alternative. So that means that P, the proportion of tickets that are groovy, is really, okay, so the tickets that are groovy, proportion of tickets that are groovy is 0.3, but we think we got a sample that made us think P is less than 0.3, and the lottery company got sued. Lottery commission got sued. All right, so in this description, describe a type 2 error. Type 2 is your banana, so no evidence. We got no evidence, so we failed to reject the false null hypothesis. Okay, so what's happening is our null hypothesis is not true. Okay, so our null hypothesis is not true, and we failed to reject it. So that would mean that the proportion and so on of the tickets that are groovy is actually less than 0.3. But we got a sample, and we think the proportion is 0.3, so we continue to get cheated. So we do not sue, we continue to get cheated. All right, so then our next one here, we've got based on the data, and I'm going to scoot this page up so that I can, and for some reason that is not erasing all of that other stuff then. Okay, so based on the data that we collect during the trial, we've got this situation where a 94% confidence interval finds that 13 to 27%. So our confidence interval is saying 13 to 20. All right, so our next number 5, we're going to see what the level of significance is. Okay, so what happens is, since the previous problem said that we had 94% confidence, then what that is doing is that is defining for us what is in the middle of the curve. So, for example, we then know that we have 94%, and I'm just kind of exaggerating the edges so I can have room. So we know that we have 94% confidence in our interval. So that means 94% of the data is there in the middle. And when it says level of significance, it is our rejection region. And this problem is about this area that is too low. So then that means our rejection, the size of our rejection region is 3%, since 94% is in the middle, then 3% is between both of the edges. So we have 3% on that edge, 3% in this tail, and since we have one tail, then our level of significance is actually 3%. Now we typically then say that's our alpha, even though, it's kind of technically our alpha divided by 2, but we say that is our alpha. All right, now we want to know about the advantage and a disadvantage to having an alpha of 5%. Well, that means that our alpha is going up. And we know that our alpha and our type 1 error are going to be the same. Our beta and our type 2 error are going to be the same. And that N and standard deviation does not have anything to do with this part here, so we don't really have to worry about that. But our alpha is going up. So we have our up arrow here, our down arrow over here. We know that what's happening is our power is increasing. Okay, so these are the ways when the arrow's on the left going up, these are ways in which our power will increase. All right, so an advantage is when our good things are happening, and that would be type 2 error is going down, and our power is going up. Okay, and then our disadvantage is going to be that our type 1 error is going up. We increased our alpha, and that's going to increase the type 1 error. So if the null is true, then we have a little bit more chance of rejecting it. All right, and then the Lottery Commission asks the researchers to extend the trial period so that a decision can be based on 1,000 tickets instead of the previous amount. That means N is going up. Okay, so we know from our little picture here that when N is going up, that is the ways in which our power increases. So our power is going to increase. All right, and the last one. If the alternative is extremely far away from the groovy tickets, in what way would the validity of our results be better or altered? Well, if you remember from our pictures that we made yesterday, if we have this situation where your null hypothesis is here, and then you have the other one, the alternative is way far away, then you have all of your information in the alternative. In this case, the alternative was actually probably in the lower direction, but you get the idea. So we basically do not have any type 2 error, and our power is, we have almost the entire possibility of rejecting the null hypothesis if it's false. So our type 2 error pretty much goes down to nothing, and our power increases depending on how far away, maybe even to 100%. All right, so we have a 100% chance then in that case to detect and reject the null hypothesis if it is indeed false. All right, so there's that problem. Now you want to go to the next page in your packet and go over the warm-up. This is our number 4, and I'm going to write that over here. So since the entire interval is below 30%, we believe that P is actually less than 30%. Okay, and you probably want to put this P, you know, with words in context. All right. Now, number 5, I'm going to go ahead and go back to that first page and kind of erase what